Hey guys, Mr. Gran here, 7.4 Similarity in Right Triangles. In this video, we are going to just go through some examples of solving problems with the properties of similar right triangles. So if we look at the first one, we want to start this out solving for side PS. So let's go ahead and mark that here. So we want to have that x. Now if we use the rule from the last video, we said that the middle squared was equal to the part times the part. So P1 and P2. Let's label that on our diagram. So this is the middle. We'll call that P1 and this P2 for part 1 and part 2. Well, then I just have to plug things in, right? We've got 12 squared. Part 1 is 9. Part 2 is x. And then it's almost set up to solve right now. So 12 squared is 144 equals 9 times x. And we just have to divide by 9. And we get that x is equal to 16. All right, for the next one, solving for QR. So now I am solving for this side. Now, when I look at this, I notice I've got a right triangle. I could use the Pythagorean theorem, and you're totally allowed to do that. For this video, I'm going to do it a little bit differently. We solved that this side was 16 already. So let's use the stuff that we just learned about. That means that the whole thing, this entire distance, is equal to 25, right? That whole distance is equal to 25. So if we use our formula where it's the outside squared is equal to the part times the whole, well, this is my outside side, this is my part, and this is the whole, right? And so that means we've got x squared is equal to the part 9 times the whole 25. If we do 9 times 25, that's what, 225? So x squared equals 225. I don't care what x squared is, I want x, so I need to take the square root, and we get that x is equal to 15. Like that. All right, next one. So first solving for CD, then solving for AC. Let's see how we do with this. Okay, so CD, right, that's this one. That is the middle. And we've got the two parts for the base. Notice this one's upside down. That's fine. It doesn't really matter. That's still the base that we're going to use. So if we use middle squared equals P1, P2, this is going to be my middle. This is P1, this is P2. I can just plug everything in. We have x squared. It's equal to 6.4 times 3.6. And now if I multiply those two, I get 23.04. So x squared is equal to 23.04. And then I just have to take the square root of both sides. If x squared is that, then x must be the square root of that. And that is 4.8. All right, with the next one, finding AC. Now, we could use the Pythagorean theorem and use 6.4 and 4.8, but for the heck of it, let's use the outside formula. So that is that O squared is equal to the part times the whole, right? So this is O, this is the part, it's the leg that's connected to it, and then I need to add these two together to figure out what the whole is. And 6.4 plus 3.6, that is 10. And 10 is my W, my whole. All right, so now if I plug everything in, I get x squared. The part is 6.4. The whole is 10. So I get x squared is equal to 64. And that's a nice number to do a square root of. We get x is equal to 8. All right, a couple more. Solving for x here. All right, I've got it set up for the middle rule. I just need a little bit more information. So the middle, I'm tripping over my microphone cord. So our middle rule, m squared is part 1 times part 2. I know I've got middle, I'll call that P1, and then this is P2. I don't know what that is, but I've got enough information, right? If the whole thing is 100, this is 25. I'm going to subtract those two to get 75 for that side. Now I can just plug it in. X squared equals 25 times 75, and that is, I'm going to guess, 1875. Boom, got it. And then square root it. And that's going to be like, I don't know. I don't know what that one is. Oops, come on now. 43.3, approximately. All right, one more. Solving for x on this one. Ooh, this is going to be an interesting one. We'll see how this goes. Okay, I've got the outside, and I'm trying to find one of the parts, but not the part that's from the formula. So if we do the outside rule, O squared is the part times the whole. Well, this is the outside. This is the part, not the x. And then the whole is the sum of these two. So what we actually have is 25 plus x is the whole. Or I'm going to put x plus 25 just because I like that order better. And that is our w. Well, again, I can just plug everything in, right? I've got 65 squared on this side. The part is 25, and the whole is x plus 25. Notice that I put parentheses around that because I need that 25 to multiply to both things. Let's start solving this. So let's figure out what 65 squared is first. That's 4225. And then if I distribute the 25 in, I get that this is 25x plus 625. Now, question, could I have divided both sides by 25 first? You certainly could. You certainly could. But I'm going to do it this way. Now I'm going to subtract 625 from both sides. What will that be? 3,600, I think. I'm going to double check before I move on. 4225 minus 625. Yep, 3,600. And then we'll divide both sides by 25, and we should be good. I think that ends up being like 144. Yeah. And 144 is equal to x.